All right. Whoa, this is loud. Welcome, everyone. Can you dial it down a bit? I feel like I'm screaming at myself, which is a bit weird. Welcome, everyone. Thanks for having me. I hope now I'm completely gone. There we are. I hope you all slept well and are well rested for a talk now. And I would love to talk to you about web components. Let's start off with a question, and I hope everyone raises their hand. How many of you have, throughout your career, written front-end code? I figured at a React conference that should be most people. Keep your hand up if you ever had to write a custom input box, like a date picker or a select box or something. How many of you thought that was painful? All right. And that's exactly the problem. In fact, if we search on NPM, there are just for date pickers over 1,200 packages that are trying to solve the problem of date pickers. And just for React, there are over 380 different date pickers. So try to find the one that solves your problem. It's a fun game. And as developers, we've been screaming particularly for date pickers for quite a while, and we're just hoping for like input type date or something, but it's not that easy, and instead, we just want to be able to just use it out of the box, just like any other kind of like native element. And this is where kind of the browser vendors were like, web components, that's the solution. And over the next 45 minutes, I would love to talk to you about why I think 2018 is actually the year of web components. And you might have heard that in 2013 or 2011 when this was actually announced. So 7 years, we're getting there. However, I really think that 2018 is definitely the year where you want to start looking at this and where it's taking off, and we've been seeing that over the last 9 months already. And hopefully by the end of the talk, you're as excited about them as I am. Before we get started, let me quickly introduce myself. I'm DOMINIK. I live in Berlin, and I work for a company called Twilio as a developer evangelist. We have a bunch of different APIs around communications that allow you to do things like sending SMS, doing phone calls, but also integrating chat or video really easily into your own applications without having to worry about like turn servers and stun servers and all the stuff you need to do for WebRTC. If you want to chat about that or anything else, you can either hit me up on like Twitter or via email, or you can just come and find me throughout the next 2 days. And I've been doing web development pretty much since I started being a developer. And since then, sort of the idea, the problem was always like, how do you share UI concepts between different applications and different projects? And there have been different approaches to solve this problem, just using sort of the web by itself. The first one I call sort of the Bootstrap approach, because probably the most people are kind of familiar with this from there. And it's the idea where you include a bunch of HTML and CSS from some CDN that you have no idea what this is doing. It's like typically 4 statements or something. You're not sure which version of jQuery you will need for this. And then once you have that, you're good, your project is set up, now you want to use a component, so you go back to the documentation, you copy a bunch of random stuff, dump it in, and now the fun part begins, because you might be using a different templating engine, so you need to fix that first, and then afterwards you're like, which properties do I actually need, and what if my alert doesn't want to have a heading? Can I just remove that, or will that break the CSS? What if I drop the role alert? What if I just forget about it because I wrote it from hand? Do I need alert success, or how does an alert look like this? And what is MB0? So it's like it's not very descriptive in a lot of cases, and it's very hard to figure out what's going on here. So another more descriptive approach is the JavaScript API idea. So you load in a global SDK where you that exposes a function, global function, where you typically pass in a DOM node, and you can pass in some options, and you're like, do it, and it will just dump a bunch of random HTML into it that you will never really take a look at. This would look like similar to this. This is the Google Maps API. They actually take it one step further, where they say like, hey, you load in the script and it's asynchronous and will load at one point, so you will have to expose a global function to us so that we can trigger it, so that then you have that available, and then you can pull this in. And you need to then pass in a DOM node, which is always fun, because you need to make sure that that one is available as well, and all this sort of stuff. So there's another approach. I call it the share button approach, because like Facebook does this, and like I think it's like one of the most common ways for them to handle these UI approaches. So you again load sort of like, it's a sort of mix of the previous two. So you actually need to have a specific DOM node available called fbroot, and then you load a bunch of JavaScript, which basically that's just JavaScript to load asynchronously a script. They just want to make it look fancy. No, it's like, it's a bit more backup to having async support, even if it doesn't exist in the browser. And then you put in HTML that has to be formatted in a very particular way. And again, you start sort of like having those questions, what things are needed. But like the bigger part here is that you can have a fallback, which is really awesome, but we're using the same URL twice here. So data href is the one that is needed for the share button, but then you also need in the href of the a tag as a query parameter the same thing. And that kind of leads to a very poor developer experience because all of these approaches work well if you write plain JavaScript and like have some basic HTML. But as soon as you throw in a framework or a library into the mix, such as React or Angular or Vue or really any of these, it gets way more complicated since a lot of these kind of like encourage you to have like DOM access and stuff like that, or like use global scripts that are not really like hard to put into your build chain and stuff. This becomes very complex and doesn't really like create a good user experience. So we're at a React conference, so you've been thinking probably the entire time, like, hey, Dom, you're doing that wrong. The solution, if you want to use a Facebook share button, don't worry, you just npm install React Facebook, and then you import the button, and you throw that into your page, and you're done. And that's true to the fact that, like, it works. But if you, like this library, for example, has not been written by Facebook. It's not maintained by Facebook or anything. In fact, under the hood, it just uses the Facebook SDK. So I looked at the source code, and it's like, it creates a new Facebook instance, and then it creates a new UI element called share, and that's it. So that means that if Facebook, for example, changes the API, adds new features, fixes security issues, we'll need to wait until that is being bubbled up to the wrapper component as well. And we see this wrapper component sort of in every framework trying to solve these issues. And some of them lack features, some of them of like the original API, some of them like are behind on security fixes and stuff. If we look at something like MDL, which is Material Design Lite, so it's like the Bootstrap equivalent for material design. There's 152 packages. Most of those are wrapper libraries. So there's one for React, for Vue, for Preact. And if you look at all of them, they have different feature sets to support these. Even though like there's a very specific set of features that are supported by MDL, specific components, they are not all supported by those wrapper libraries. And that can be very frustrating for you as a developer as well. Because then you end up writing your own wrapper again, and why did you use a library in the first place then? So the idea was sort of how can we use components as easily as native elements, because any of these frameworks, they're used to working with native elements, right? Like we all use input tags, the video elements and stuff like that, and like all of these frameworks are used to being able to treat these. And you can use them on things like static websites or A/B testing tools very easily. And since HTML element is actually a built-in class in the browser, out of which like other elements like the input element actually properly inherit, why can't we do the same thing for our own custom components? And this is where web components come into play. And most people think of web components as one massive spec. It's actually a series of specs that are just typically kind of like mentioned in the same context, but they're implemented at different stages. So the first one is custom elements. And custom elements allows you to extend HTML elements, just like I've been talking about. So the way this works is you just create a new class. It has to be an ES 2015 class. It can't be prototypal inheritance. And it extends the HTML element. And then in there, once you have the constructor or certain callbacks are being triggered, you can start rendering things. And then you call custom elements that define. You give it a tag name. And then you pass in the class. The tag name has to have a dash. This is what the browsers agreed on to make sure that this is future-proof. If the browser, for example, decides to add a native date picker, they would not be allowed to call it date-picker. They would have to call it date picker, for example, so that they're not clashing in the future. And the nice thing is you can also extend or augment existing element. So in case, for example, we want to make our date picker extend from an input element, we can do that as well. We just pass in another option called extends and pass in the input element, and then also extend from the HTML input element instead. And once we have that, we can use it just like we're used to from any HTML element. We can either use it in a declarative way in our HTML, or we can use it in an imperative way in the JavaScript API by using document.createElement. And since we can use it in document.createElement, that means we can also use it in tools like JSX and other stuff, because under the hood, it just does the same thing. When we talk about custom elements, one thing that is important to keep in mind is something that a lot of developers don't really constantly think about, and that's the difference between attributes and properties. So an attribute, if you're not familiar with it, is specifically the thing you put into HTML, for example, the disabled or the value thing. And it allows you to pass information into a component, but it can only use simple data. So the only options are you either pass in a string, like the value thing, or you pass in, or it's a Boolean one, meaning it's either present or not. Disabled, for example, I commonly see people who are new to web development kind of setting like disabled equals false. That will still be present, therefore it's still disabled. And then properties are on the instance of the on the JavaScript instance of the element. So if you would like pick it out through query selector, then you would have all of these properties you can access. And typically, in some situations, they're reflected back into attributes. Like disabled, for example, would be reflected back into the attribute. It would like remove it or not. But it doesn't have to. Like a good example is text inputs, for example. Typically, they don't reflect the property change back into the attribute. React has been doing that, but they're talking about with React Fire now to kind of remove that as well. And the nice thing for properties is that they support complex data as well. So we can pass in arrays, objects, or anything like that, because it's just a JavaScript property. The problem with custom elements is that you need to do this sort of reflection and keeping in sync yourself. And that creates a lot of boilerplate code. So, for example, if we want to keep the disabled property in sync with the attribute, that will mean that we would, first of all, have to create a getter and a setter for the properties, and then we always set it back to the attribute. If we want to do it the other way around, we could listen to the attribute change callback to then trigger functionality based on an attribute being changed. For example, if you want to break down an attribute into multiple properties. The next spec is HTML templates. So HTML templates is literally an HTML tag called template, and that allows you to specify HTML inside that tag that won't be rendered, but can be very efficiently cloned. The way this looks is you create a template element and then specify inside. You can specify styles, any HTML, and it won't be displayed until you actually clone it into an existing node. And you can also have a specific element called slot, which we'll talk about later. And then you can clone this, and this is the most efficient element that can be cloned in the browser. The third spec is called the shadow DOM. So shadow DOM allows you to hide underlying implementation to the user. From the user, and scope styling. So you don't have to worry about if you would style all the p tags in your component with a certain style. This cannot bleed out, and similarly, it can't bleed in. So this is something that is being used by a bunch of native components like video, text, for example, that have their own shadow DOM, so you can't accidentally restyle all buttons or stuff like that. But you still have an API that allows you to interact with it and change stuff. The way you use shadow DOM is you're able on HTML elements to call this.attach shadow, which will create a new node. And then in that, you can append children. So in this case, we would clone the template we have and clone that into it. This is how it would look like roughly when you look at it in the inspector, and we'll do that later. If we would have a date picker and we would pass in a child, that one would actually appear where the slot is. It won't actually place it in there, and we'll see that later. It's more symlinking it basically in there, which means that if you would style the paragraph at the top, those styles would still apply to it, but anything else wouldn't be styled by this. And similarly, those global styles in the shadow root wouldn't bleed out. And then the fourth spec is HTML import, and we don't have to talk about them because they're dead. They've ever only been implemented by Chrome, and that was before ECMAScript modules came around, and the browser vendors kind of figured out that that's the better way to go. There is talks about creating a spec about HTML modules, which kind of take the learnings from HTML imports and ECMAScript modules and try to figure out if there's a solution that kind of allows you to also better import CSS and HTML. But for now, we don't have to kind of worry about that because it's not directly on the roadmap yet. So what's the support? The support is actually pretty good. HTML templates and ES modules have been implemented by all major browsers. Custom elements can actually be really easily polyfilled, but they only have to be polyfilled by Edge as of the latest version of Firefox, which is currently still in beta, but they have now full web component support as well. Shadow DOM is a bit harder to polyfill. They basically do a similar approach to CSS modules or things like CSS and JS, where they try to generate CSS classes and attribute names to kind of ensure that styles are not clashing, but it's not perfect because there can still be like style bleeding. But it helps you to kind of get started if you want to be ready for when everything is supporting it. So why should you care? First of all, if you develop a UI component in general, this will exposing it as a web component allows you to have a larger user base. Because you're not limiting it to your framework of choice anymore. You can also let other people use it with their framework of choice. If you're in a bigger company, this is really useful because everyone can kind of rely on the same tools. So EA does this, for example. They have a bunch of microsites that are using different frameworks, are being developed by different teams, but their entire UI kit is being developed with, in their case, Polymer, using web components so that they can easily share this with other developers in their company, and they can just use them without having to worry about kind of, is this available in my own framework? And even if you don't fit into any of the two categories, you will still benefit from a better developer experience because, as I said, like native elements is something that every framework kind of knows how to handle. And being able to have more of these elements just makes it easy for you to use that without having to worry about, is it a global JavaScript SDK or something else? A good example of this is actually called A-Frame. How many of you heard of A-Frame before? All right, for the people who don't know A-Frame, A-Frame is actually built using web components and 3JS and WebGL, which allows you to create really easily web VR experiences by just using declarative HTML markup. I figured I'm just going to show you a quick example here. So let's load this. Cool. So I already have like so we have a world here, like some cube that's rotating around, and a text called "Hello React Alicante." And if I jump into the code, even like most of the audience said you don't know A-Frame, I think everyone can read what's going on here and gets an idea of what's going on. Can make it a bit bigger, but basically, I can immediately spot that like "Hello React Alicante" is here, and we can see the color that it's using. I can add additional exclamation marks here, and if I switch back to the app, we can see now we have three exclamation marks here, and it's just very easy to use because it's just HTML, meaning that we can also use this in React really easily, or in Vue, or anything like that, without having to worry about like how do I need to create wrapper components around this or anything. Cool. So let's go back. Another example is you can use web components nicely for progressive enhancement. So a colleague of mine, Phil Nash, wrote a web share wrapper. So the web share API is still being implemented by browsers, but he wanted to have a way to easily use it without having to worry about like how can I what happens if it isn't available. So he wrote this wrapper library, and it's basically a web component that allows you, similar to the share button we've been talking about earlier, to put in an A tag, for example, as a fallback or anything else, so that if custom elements are not available, sure, it will just use the A tag. It will just display the A tag. If they are available, but the web share API isn't, it will still fall back to that. If both are available, in that case, it will use the web share API, and he's able to like pass an additional information there. All right, so if we talked about this for so long, for like 7 years now, why didn't this happen earlier? And the first thing is browser support. It took a while until the browsers would implement everything. The first spec that was talked about in like 2013 mainly was still Web Components v0. We're at v1 now, but a lot of browsers were still hesitant to implement it. And that sort of connects back to also the low-level API that Web Components actually exposes. I said there's a lot of boilerplate code you have to write when you get started with Web Components, and that's due to the Extensible Web Manifesto. If you're not familiar with that, it's sort of a contract that the browser vendors agreed on to when they're developing new specs, what sort of things they want to adhere to. And in that, there are two particular lines that sort of explain the way Web Components came to be. The first one is the standards process should focus on adding new low-level capabilities to the web platform that are secure and efficient. So talking about low-level APIs, that's exactly the sort of, that's why it is so low-level. And WebGL, for example, is the same thing. You tend to not write WebGL code yourself. You tend to use things like 3JS or other tools to generate this WebGL code. And then the web platform should expose low-level capabilities that explain existing features such as HTML or CSS, allowing authors to understand and replicate them. So rather than introducing a date picker itself, and then the developers start screaming for a pay element, and then for something else, the idea is more to have give the low-level APIs to the developers so that they can build what they need. And similar things are happening now with the CSS Houdini API, for example. If you want to learn more about that and also like why it took so long to standardize this, I suggest to watch this talk by Monica, how the web sausage gets made. She does an amazing job in explaining that, way better than I could. So I recommend checking that out, and I'll share the slides if you want to check out the link later. And then the third one is tooling. Since the API is so low level, that means that we need to have some good tooling to be able to use this in a very convenient way. And for a long time, this meant that you could either build like your web component in like just with the API, or you would use Polymer. And a lot of people weren't really fond of Polymer or didn't want to build their entire app in Polymer and were confused by that. But over time, first of all, Polymer drastically changed and improved, but there's also a lot of other tools available now. We have Stencil, we have Glimmer, which is the rendering engine in Ember. We have Skate.js, Angular, and Vue are both looking into like having a way to easily convert their elements into custom elements. In fact, Vue's components already look very similar to custom elements. And that allows you to kind of like have way more freedom of like how you want to implement it. Because ultimately that in the future allows you to kind of pick your own favorite framework and own favorite way of writing components, but then let others pick their own way of like consuming them. And I figured let's stop talking about theory and start actually building stuff. And I figured let's get rid of date pickers at all and like build the very last one. Then again, it's 9:30 in the morning, and I don't think we want to spend the entire day here. So instead, let's build a rating component, because I feel like that's a bit easier. And before I tell you what kind of rating component we're building, one more background about me. I'm part of a group called Onesie.js. We love wearing onesies, and we're JavaScript developers, so Onesie.js. That's typically me on stage, but I figured Alicante is a bit too warm to run around in a onesie, so I left that one at home. But that means we're going to build an emoji rating component that allows you to later vote on my talk using panda emojis. And for that, we're going to use a tool called LitElement. So LitElement has been written by the Polymer team. It's going to be the new base class for Polymer element, but it allows you to, it's declared as like a simple base class that allows you to easily create custom elements using lit HTML. It's using completely web standards, which means we don't need a compilation tool or anything, except that since I'm going to use bare modules, I'm using Parcel as a bundler just to do the module bundling. But if you would use proper ES modules, meaning you specify the entire path, you wouldn't have to transpile this. And then LitHTML is actually based on HTML templates, which makes it very efficient without using anything like the VDOM or something. And it uses HTML tag template. So I'll show you in a second how this looks like. If you want to check it out, again, the link is in the slides, and I'm going to share the slides later. But for now, let's do some live coding. So I'm going to duplicate my terminal. So that's for later. I have a project set up. It looks like a lot of files, but it's mainly configuration files. If we actually look at the package.json, I have one actual dependency, which is LitElement, and then just roll up because I actually published this to NPM, and the web components polyfill for later. And then we have an empty file here, so I love starting with empty files. So we're going to start off creating just a normal class, so emoji rating. And it's going to extend, as I said, LitElement is a base class, so we're going to extend from LitElement. We need to pull it in from the Polymer LitElement class module, and then we have to custom elements define our. I wonder from which snippet that one comes. Emoji rating, and then we pass in our class here. The one thing you need to implement for LitElement is a render function or a render method, similar to React or most other frameworks these days. And here we need to return LitHTML. So we're creating an HTML tag. Oh, no, what's my settings? That's the button. So we're creating an HTML tag template. I actually installed a VS Code extension here, which allows me to have proper IntelliSense, similar to JSX and stuff like that, so that we have proper autocomplete and stuff. And then for now, I'm just going to display a panda here. To see if it works, let's consume this. So I have a basic website here. Let's kick this off, npm start. So as I said, this just kicks off Parcel. That's the wrong tab. That's the tab. So for now, we don't have anything. Let's use this. So as I said, it's just an HTML tag. And then we need to consume our script that we just wrote. And there it is. So we have our panda here. And that's how you can get started with a custom element, but obviously we want to do a bit more. So let's start by having actually attributes and properties. So the first thing we're going to do is we're going to create a static getter called properties here, which LitElement uses. There's different ways in LitElement to do this, but I figured this is the most sort of almost prop type style thing. And in here, what we're going to do is we're going to say we have two properties. One is emoji, which is of type string. And then we have another one that is called value, which is of type number. You could also pass in functions here, for example, to specify how it should be parsed. You can specify additional properties, like should it reflect back into attributes or anything else. But for now, we're just going to keep that. And then you can give it default values by placing this into the constructor. So we're also going to add two more here, this as min and max. We could add these to the properties as well, but I want to show you later what the difference is. Going to give it a default value of a panda. And then, oh, no, that's emoji. And then the default value is 0. Since I'm inheriting, I need to call the base constructor. And now that we have that, we're able to just grab these out here. And emoji. And now we can specify in here, let's create a class first, rating and a role range. And we can properly make this we can make this properly accessible, so we can just use string interpolation anywhere where we want to. And LitHTML is going to figure this out. So I'm just going to copy these properties and like make it proper. And then one for value now, which is value. And I screwed up somewhere. There it is. Cool. So we have that. Let's wrap this over to the next line. So if we go back here and we pick this, we can see we have the shadow root here that I was talking about earlier, and then we display all of our stuff here. The values have been interpolated. I wrote min here as well, max. The values have been interpolated, and we're able to pick this out, this emoji rating, and if we go here and, how do I drag? There's the dragger. Come on. There we go. And if we set, for example, the value now to 2, we can see the values being automatically updated here. As I said, it's not automatically reflected back into the attribute here, but we could also set the value here to 5, and we can see it's being reflected here. And now if we read the value, we get it as 5 as well. So we already have this kind of connected without having to write all the boilerplate there. Now let's render an actual rating. So I'm going to create an emoji array. So I'm just going to do repeat max. And to have efficient re-rendering of a list, there's a helper in LitHTML called repeat that we can pull in from LitHTML directives repeat. And that one just gets an emoji array in this case, and then a function to render this. We can also have an indexing function if you want to make sure that certain elements are not re-rendering. So I'm just going to have a render emoji function. The reason why I'm prefixing this with an underscore is that what LitElement by default does is that everything that's prefixed with an underscore is hidden away. For the custom element, everything that is not prefixed is can be accessed just like a property as a method. So if, for example, in a video element, start, stop, these sort of methods, you could expose them. So I'm just going to bind this to the right context. And in here now, we need to also return, I didn't write repeat. So in here, we also need to return HTML. So I'm going to give it a class like emoji. And then in here, we can render our emoji. So it looks very similar to sort of what you're used to from JSX, just that it's actually, since it's HTML tag templates, repeat is not defined. Oh, yeah. So if you have an extension installed that cleans up your imports and you don't use it, your editor cleans up for you. Got it. Thank you. See, that's why I love live coding, because we can do pair programming. So now we have 5 pandas. That's already good. Let's give them some style. I'm not going to write all that CSS for you in front of you, but now we have 5 black pandas. If you're more into pink, I'm using a CSS variable here, and this is the nice thing of being able to use the shadow DOM is you can expose a clear API of what you want to let the developers tinker with. Instead of letting them play around with everything, you can be like, you can change the color, but I'm not letting you change the arrangement or something like that. And we can just use that as any kind of CSS that we're used to. You can use this in CSS and JS if you want to. And we just set the value here. So I'm going to set it to pink. And now we have pink. And that way we can have a very declarative API of what things you can change in CSS. And now, since we did this, I can also do value 5. Oh, yeah. Wait. I forgot one thing. We need another class here. So if the index is smaller than the value, then we do active, otherwise nothing. And then we just interpolate that class in here as well. And now, if we pick this and set it to 3, we can see the 3 pandas. And now I told you I wanted to show you the difference between like specifying something in properties and just setting it as a property. If I set max to 3, nothing happens. But as soon as I trigger a property, let's change this back to. As soon as I change a property that is specified in properties, now LitElement knows it needs to trigger a re-render, so it will trigger that. So LitElement doesn't have the concept between like state and properties. It's just all properties because that's how the browser handles it. So you just need to trigger like the render, like either manually or in this case, LitElement will watch out for it. All right, we want to be able to click on it, so I'm going to do an event listener here as well. Just have like a handle click. We're just going to get a click event. Going to, again, bind this to the right context. And what we're going to do here is we're going to grab the value as, and now we need to parse it because I'm going to pass it in later as event.target.dataset.index. We're going to pass it with parse it base 10, and that means we need to pass it in here. So I'm going to do data index, and then we also need to register it. So LitElement uses the at notion to specify which event it would be, and then in here we just say this dot handler click, specify that, and then what I'm going to do here is like if the value is the same as the current value, I'm just going to reset it, so you can also give my talk 0 pandas if you change your mind. And you're like, what? Why is he not talking about React? And then now we have that. Refresh, and now we're able to click around with this. The last thing I want to show you is another basic concept of elements, which is event listeners. So we should be able to, since this is like some sort of input, basically, we should be able to query selector it out, and then add an event listener to it. So change, and then be able to listen for the event, and console log the event.target.value. Right now it doesn't do it. It's not that difficult though. Let's mark this function as async because that way we can await for this.update complete, which is being resolved every time like the values are being all updated and the rendering has been done. And then we can dispatch an event, create a new custom event here. And this is just browser code. This is nothing LitElement specific of like creating a custom event. That's why I don't need to import anything. And then we can specify as a detail the value just so we have it passed in there. I refresh, and now we can see it's being triggered here. Cool. So I'm going to stop this. I already pushed this code to NPM, so you don't have to watch me publish stuff on NPM, which I think is not that exciting. Cool. So let's talk about Stencil, because that's typically one that I get questions about. So Stencil, if you are not familiar with it, was written by the Ionic team. Ionic is more known, I think, in the Angular community than in the React community. But it's basically a bunch of UI components that allow you to create really nice looking, native feeling UI, like hybrid apps based on Cordova and, but also like for like Electron and other things. And Stencil is a compiler that generates web components. It's built to bring Ionic to more frameworks than Angular, because that was initially the idea of Ionic. But then they realized that there are too many frameworks and they don't have the time to maintain them all. And it's inspired by a lot of different frameworks like Angular and React and others. It uses TypeScript, decorators, and JSX. You can check it out on Stencil.js, but if you want to just get an idea of how this looks like, this is sort of the example component they have on their website. So if you're familiar with Angular, you will see that these like add component, add prop sort of decorators are very common there. In this case, we specify meta information like a tag name and the style URL, so you don't have to do custom elements.define or anything. And additionally, you will then have a render function where you return JSX. So you see it's a very different approach to LitElement, even though the code looks very similar, because we're not extending anything here, that's all done by the browser, by the compiler. The compiler will magically change all of this. So you're further away from the web standards, but you can use tools that might feel more familiar for you. What if you love React, though, and you just want to use web components with React? This is actually on the React documentation, so you can check that out as well. But you can just render your React component into a custom element. So basically, you would attach the shadow root and then place a mount point in there, and then like use React DOM to then actually render your component in there. With that, we have 5 minutes more. So let's actually use the component that we wrote rather than just like letting it fall apart, and so that you can vote on my talk. I created a basic create React app. I changed it to React App Rewired because I needed a different minifier. But that's pretty much it. So let's jump into the index here, and what we're going to do is I'm going to import the emoji rating. As I said, I pushed it to NPM and already installed it here, so you don't have to watch me do that. And then I have a component here, so let's see how this actually looks like. Starting it. All right, so that's my app. And we want to put in here a rating component. So how do we do that? As I said, we already imported the library now. So all we have to do here is emoji rating. Save that, switch back. We have our rating component here. It's working. We didn't have to do anything. Now, the colors are not that great. So let's fix that. Again, as I said, this would also work if you want to use this with like styled components or any like CSS and JS solution. And we're going to use the same API that we exposed earlier and change this to white. And now we have like a white background, so that's cool. And now, if I show you this, we see the pandas down here are not being updated. Obviously, we need to connect this to the state. And what we can do here is we're just going to listen on the onChange event, and then handle vote change. It's way too early to come up with like creative names here. Cool. So I have that. Let's wire this up. All we have to really do is get again like the event here, get the current value out of that, and then call this.setState on the current value. And now if we change this, that works. As I said, we can pass in properties, attributes here, like emoji, and change this to unicorns. Because who doesn't like unicorns? There we go. I'm gonna leave it to pandas though, because that's what it says in the text. Now, the thing is we can set attributes here. Unfortunately, we can't set properties. We can if we use references, but in React right now, there's no way for us to set properties through this, but it will always just set attributes. There is work in in the React community. There's discussions around how we could change that. The nice thing is Preact actually allows you to do this. If you would pass in more complex data, it would set it as a property instead of an attribute. If you want to do that and you use React Rewire, you can do what I did and just use Rewire Preact, and you can keep on writing your React code and then run it through Preact, and that will solve that problem for you. So there's a couple of still gotchas on that node. You can check those out actually. Oh, let me first get status. Let's deploy this so you can actually vote. Cool. So I'm wrapping this up. If you want to check this out, there's a website called Custom Elements Everywhere. It's great because what it does is it continuously runs tests against all common libraries and frameworks to figure out what kind of drawbacks they have. So Preact is doing actually pretty well. It has some issues with mixed casing events and stuff like that. React is, where's React? I think I passed by it. There it is. React can do better. As I said, the basic tests pass, so you can use basic components. But there's things like, for example, React still uses a synthetic event system, which they're planning to get rid of in React Fire. But that means that you can only use events right now that are actually on native elements. So if you want to use that sort of thing with custom events, then you need to bypass it by using Preact, for example, which allows you to do that because it relies on the web standards. But this is all explained here as well, how you can actually handle all of these. And it continuously runs these tests, so you don't have to, it's always up to date. Cool, so this is pushed. Let's actually see, I think it's not deployed yet. Maybe it is. Yay, it is. Cool, so you can actually go and vote for my talk. I'm going to show you the slide in a second. And let's wrap this up. So I want you to think about web components whenever you build something that you want to have as shared UI. So you shouldn't think of every component you're writing as a web component. It's the thing you want to share with others that you want to think about as web components. Because web components are not here to limit your framework choices. You shouldn't have to build your entire app in web components. They're just here to help you share your work. Because ultimately, you should be able to pick your favorite thing and let others pick theirs. And hopefully, we don't have to write date pickers anymore at one point. Rob Wormwald from the Angular team has this vision of never having to write a date picker ever again. If you want to check out more about web components, the spec, as well as look at some example components, webcomponents.org is great. It also has a chart of which browsers support what yet. Most of those components still use HTML imports. There are some that start using ECMAScript modules now. Custom Elements Everywhere, as I said, is a useful resource. If you want to look at different web component frameworks, there's a web components to-do thing that allows you to look at how different things are implemented in different frameworks, and there's constantly new ones. I also wrote a blog post about how to build web components with Stencil, if you want to check that out. The slides are on this URL, and I'm going to tweet this out. If you look at my Twitter, you will see that. The emoji rating component is live there. I did some updates yesterday. Webcomponents.org, Custom Elements and Everywhere, and the web components to do are sort of the most useful resources to get started. As I said, this is the URL if you want to vote for my talk now and give me pandas. And with that, thank you, everyone. I'll be around if you have any questions, and I'll let you have Sarah talk about actually React now instead of me talking about other stuff. Thank you.
Yes, since we started a bit late, simply try to find Dominic later if you have questions, okay? Thanks.